Hi, I'm Dr. Alexandra Yeung and I'm a lecturer at Curtin University, and welcome to one of our many chemistry labs here at Curtin Bentley campus. Today we are going to determine the acid content in wine through a process called volumetric analysis, otherwise known as titration. The titratable acidity, also known as total acidity, is commonly measured in grams per litre. However, it can also be expressed as a percentage. Tartaric acid is the main acid in wine and gives the wine a tart, crisp taste. It is a diprotic acid, meaning it can donate 2 protons, and is the most concentrated acid in wine. So when determining total acidity of wine, it is assumed that total acidity is due to tartaric acid. So why do we want to know the total acidity in wine? Well, the total acidity in wine can influence its taste. For example, a dry wine has a lower total acidity, while a sweet wine has a higher total acidity. Now, just to recap of what a titration actually is, a titration, often called volumetric analysis, is an analytical technique that allows us to determine the concentration of an unknown sample using the concentration of a known sample. We have our tartaric acid. We're going to be reacting that with sodium hydroxide, which produces sodium tartarate and water. In our case, the sodium hydroxide is our known sample. So the known sample is often referred to as the titrant. Our unknown sample, which is our tartaric acid, is often referred to as the analyte. Now these things here go into the different equipment that we'll be using. So the analyte will know the exact volume, will end up going into our conical flask, and that exact volume that we use is called an aliquot. Whereas our titrant, or our solution of known concentration, goes into our burette, and the volume that's delivered from the burette is called our titer. Now, as you can see in the reaction, we have a 1 to 2 mole ratio, which we'll need to bear in mind when we're doing our calculations later. One thing to note when we're reading our burette and our pipette that we use to deliver our aliquot is to make sure we're reading it correctly, and the way we do that is we read the bottom of the meniscus. So imagine this was our burette. The bottom of the meniscus has to touch the line of our reading here. Another thing to note is that it has to be in line with your eye level so that we don't get any parallax error. Today's titration, we're titrating our strong base, which is our sodium hydroxide, with a weak acid. When that happens, we have to make sure we're choosing the correct indicator so that we know when to stop our titration. To do that, we have to know where the equivalence point is. And that's the point at which all the acid and base has reacted according to the mole ratio of our equation. If we have a look at the titration curve, so you may have already seen this something like this before. We have our pH on our y-axis and the volume of sodium hydroxide on our x-axis. So we start with an acidic solution, which has a low pH, and as we add the sodium hydroxide to the conical, the pH rises. So in the beginning, our acid starts off with a yellowish colour. As we add more sodium hydroxide, we end up at the equivalence point. Now if we go past the equivalence point and add too much sodium hydroxide, we end up with a very, very pink colour. All right, now we can get started with our titration. So to begin our titration experiment, we need to get all our equipment ready. First thing I'm going to do is fill our burette with our titrant, or the solution of known concentration. In our experiment, it's the sodium hydroxide solution that we're using. Also to note, as a safety precaution, to wear gloves when handling your sodium hydroxide, because it is corrosive and it's best to avoid skin contact. We're using a very, very dilute amount, 0.097 moles per litre. So to fill up our burette, we have to make sure we don't fill it up above eye level like this, because it's really, really dangerous and not a very good way of doing things. So we need to bring it down below eye level, because I'm short. Make sure the tap is closed, otherwise you'll end up with a puddle on the floor. And then we fill up our burette. Okay, when reading the burette, we read the meniscus to 2 decimal places. And this one is 0.65. Next thing we're going to do is put our analyte, or the solution of unknown concentration, our wine, and we're just going to pipette it into our conical flask. Now, when you're using a pipette and a pipette filler, you hold your pipette at the top end, not on this end. There's the potential of the pipette to break and you could end up stabbing yourself, which is not what we want. So to fill up our pipette, place your pipette filler on the top of the pipette, just enough to get a seal, and put it into our unknown solution, or our wine in this case. And we start drawing up our solution. So we want to draw up enough solution that it gets above the line on the pipette. As soon as the line is above, take the pipette filler off. So now I can see why you don't want to shove it on, because it's hard to get off. And then slowly twist so that the bottom of the meniscus ends up at the line. So we've got there, we transfer this into our conical flask. So we basically just let it all drain out, and at the last point, we touch the conical on the side of the glass, and the final drop will come out. And that's what's supposed to happen. You take it off, and you may notice that there's still 1 drop in here. Don't try and blow it out, because it's supposed to be in there. So we've got our analytes. We've got 20 mils in our conical flask. The colour is not quite clear. So to help us see the end point, I'm just adding 30 mils of deionized water. The last thing we have to do is add our indicator. So the indicator we're using is phenolphthalein, and we only add 2 to 3 drops. And we're ready to titrate. When we titrate, the best thing to do is swirl with your dominant hand and control the tap with your non-dominant hand. Okay, so when we do it, our first run is going to be a rough one, just to see roughly what volume of sodium hydroxide we need to reach our endpoint. So to start, we basically open the tap and slowly run out the sodium hydroxide. You'll see a slight pinky colour. That indicates that there is sodium hydroxide being added, and that pinky colour will start staying longer when you're closer to the end point. If you wanted, you could use a white piece of paper so that you can see the colour change a bit better as well. So this is our rough titer. So we just record that volume, 17.15. So that's our first rough titration. So we can work out the actual volume that we used. So you can just use a calculator for this. 16.5 mils. So that gives us an indication of roughly how much we need to reach our endpoint, or the equivalence point of the reaction. Next thing we have to do is repeat the experiment so that we have repeated readings to give us a more reliable result. So when we're repeating our titration, unlike the rough titration we just did, we have to be a bit more accurate and go a bit more slowly when we're almost at the end point, because we want to pinpoint the exact point at which the indicator changes colour. Another good technique is to ensure that everything that's inside the conical is actually in the solution and reacting, because you may have some droplets on the glassware that's not actually reacting. Squirt a bit of the water in there, and on the burette, to make sure everything is inside, and then we keep going. So at this point, we're going to just go very slowly, unlike our rough titration, so that we can actually see the drop that causes that colour change. So when you're almost at the end point and you want to add maybe half a drop instead of 1 drop, you let the drop come out of your burette, just sitting on the tip. Then you grab your deionized water bottle and squirt in that half a drop. And that may be it. All right. So let's just check. Yeah. So that's our endpoint. All right. So it's not quite yellow. Okay. Good. And it has been a permanent color change. There we go. All right. We hope you enjoyed our titration experiment today and found it knowledgeable. Our next video will continue the experiment by doing calculations needed to determine the acid content in wine. If you would like to find out more about studying chemistry or a science degree at Curtin, head to study.curtin.edu.au.